Macaulay duration. So duration is a measure of the sensitivity of the price of a bond or other debt instrument to a change in interest rate. There is the need to introduce this kind of quantity because time to maturity, which is the remaining time after which the contract is expired, is not enough because financial effects due to intermediate payments are not taken into account. Therefore, the interest rate effect on these intermediate payments are not taken into consideration. This information is especially used by portfolio managers in order to manage interest rate risk between assets and liabilities. Specifically, Macaulay's duration, which is what we are going to deal today, measure the weighted average time an investor must hold a bond until the present value of the cash flows is equal to the amount paid for the bond. So now we are ready to introduce all the quantities needed to derive the Macaulay's duration. Therefore, we have our flow of payments that is denoted by the vector x, which is composed by m elements, where m denotes the maturity of the instruments. Then we have a set of dates t, which is denoted by this vector, and it has again the same number of elements of the flow of payments. Then there is the term structure interest rate, denoted by I from t to s, with s bigger than t. Then we denote the duration as this formula, which at the end it is the weighted average of time, the weighted average of time weighted by the present value of the cash flows. And for at the end, Macaulay's duration returns a number which expresses years, month. Now we are going to deal with a practical example with a financial operation, which is in this case it is annuities, which is an annuity with constant payments, and we will derive a mathematical formula for the duration of this financial operation and show how does it depend on the interest rate. Since it has constant payments, xk will be equal to r, will be constant. We will denote by tk equal k, and therefore the duration of this instrument it is has the Macaulay's duration is defined. It is in this way. Now we are going to develop mathematically both the denominator and the numerator. The denominator, therefore, it is the sum from 1 to m of 1 plus the interest rate, and it is assumed constant, power minus k. Then by simplifying the inverse of the sum between 1 and I with v, we have this formula, which is a geometric series, and it is our denominator. Then we put the denominator, it is equal to, at this stage we expand the series, which is v, the sum from v to vm, v power m. Then we divide by v, and therefore we have all the elements are decreased by a power of 1. Then we put minus 1 to the left hand side, and we see that the right hand side is quite almost equal to the right hand side of the first equality, with the difference that there is not Vm. Therefore, at this stage we add to both sides of the equation Vm, and therefore at the right hand side now we have exactly d. We put d to the left hand side of the equation, and then we put v power m minus 1 to the right hand side of the equation. Therefore then we we simplify the formula by like this, and we get that our mathematical structure, mathematical formula for the denominator, it is this way, which is an application of the geometric series. Then the denominator, it is k multiplied by 1 plus I power minus k. We put the usual simplification with v, then we multiply by v by 1 minus v, we divide and multiply by 1 minus v, and then we expand the subtraction inside the summation. We expand manually the first term of the subtraction and the second term of the subtraction inside the summation, and then we see that at the end they have a common term, which is 1 minus v, and then we see that at the end it remains v, and then all the terms with the same power will have 1 as a coefficient, and then it is in fact like this, and therefore we remain with this structure. The geometric geometric series single out as we did before, and therefore we have this formula. And then we put v, we collect a v and we put it outside of the circle brackets, and therefore we have this formula. Then we just do the division between the numerator and the denominator. Therefore we can see that both at the numerator and the denominator the common term is v divided by 1 minus v. Okay, at the numerator we remain with 1 minus v power m over 1 minus v minus m times v power m, and the denominator 1 minus v power m. What we can do, we collect a 1 minus v power m on both the numerator and the denominator, because they are the common term, and at the end we remain with 1 over 1 minus v minus m power multiplied by v power m over 1 minus v power m. And by simply putting the definition of v, we have a function of the interest rate I and of the maturity m. Therefore we can see that annuity's duration is a decreasing function of the interest rate. Therefore, higher the interest rate, lower is the duration, and it is obvious because the financial instrument takes less time to repay what we have paid for it, and an increasing function of the maturity. Then we take the asymptote of the, I remember what, of the second term with respect to maturity m, and we will see that this is 0 because m goes up to infinity. Therefore, the asymptote of the duration for an annuity with constant payment r and constant interest rate I, it is this ratio, which is 1 plus e I over I. And then here there is a plot on Excel in which we can see the different duration of annuities which have different interest rate, and we can see that for example the annuity with interest rate equal to 10%, which is I3, it has a lower duration, while the annuity with the lowest interest rate, which is 4%, which is I1, underscore 1, has the highest duration. And we can then finally we can see that in the long term, therefore after 100 years, the duration reaches the asymptote. This green asymptote is the asymptote for the annuity with interest rate 10%. In fact, we see this. And then this yellow asymptote is the asymptote for the annuity with interest rate 1, E underscore 1, and we can see that in the long term they match. Thank you for your attention, and see you for the next video.